Welcome, everybody. Welcome to our session about modernizing IAS's data pipelines. Our presenters today are myself, Andy Gunther, and Preethi Krishnan. We're both staff data engineers on the data enablement team at IAS. If you're not familiar with IAS, we are an ad tech company. We sit between the publisher platforms where we integrate with different ad publishers such as YouTube and TikTok. And our clients are primarily advertisers themselves. So some of the data that we process 280 billion interactions per day, and we help advertisers really recognize the, sorry, I'm stumbling a little bit. We help advertisers recognize the, sorry. Okay. We help advertisers recognize their, I'm stalling. I need just a moment. Can you help me out for a second?
The media measurement and optimizing their platform for finding the right ads for the context.
Yeah. I'm completely freezing up. Sorry about this, everybody. So, yeah. Thank you. We help advertisers optimize their platform. So we track those advertisements, we track the measurements of those ads, and then once they're tracked, we give them recommendations about how to improve their ad campaigns. So moving on here, the agenda that we're going to talk about today, first we're going to talk about why we chose to go with Databricks. Then we're going to talk a little bit more about how we moved into Databricks. And then Preethi is going to follow us up with talking about some of the tools that we built to enable different teams to adopt the platform. And then we have a demo for you guys at the end. So first up is why did we pick Databricks? So we had a few goals as we were getting started. First of all, we wanted data to be more discoverable and accessible. So before we had all of our data in AWS, and we had different tools for some of our data pipelines, it was hard to really identify who owned a specific data set, and we wanted to improve that. We also wanted to scale our product development pipelines. So to scale, we not only wanted to scale the performance of our pipelines, but scale the ability for developers to actually use those pipelines and scale the speed at which developers could build out new pipelines. We were looking for something that we could have, that we could keep stable and reliable. We wanted to reduce barriers to actually get access to the data. And then we wanted to improve our customers' speed to insights. Finally, we also wanted to kind of standardize our data platform tool set. So instead of having like mismatched different tools across the company, we wanted really one unified tool set that it was easy for a developer to kind of work on different teams and still have like a core base of tools that they knew and understood. So when we looked at different platforms that we could adopt, one of the platforms was obviously Databricks, and we liked it for a handful of reasons. One of those reasons was the really awesome Unity Catalog tools. So the data lineage tools were really useful. When I've worked in the past, I've tried to build my own data lineage tracking tool, which worked with some of our some Hive data sets, but what's been really nice about Databricks is we get upstream and downstream tracking of jobs right out of the box. Not only jobs, but you could track upstream and downstream dependencies on tables and the workflows and ML tools as well. Other useful tools was the table history. We could see exactly who was modifying different tables and when. And we had grants available at the individual table level or catalog schema level. Some of the other tools that we really liked was the key focus on the Spark integration. IAS used a lot of Spark before we moved into Databricks. And some of the bonus features that Databricks had out of the box were really useful, such as using notebooks to test your data sets, test your code, instead of having to deploy a job in order to test things. We liked the integrations between structured streaming and batch processing. You can load data with a structured streaming job into the same table that you would load data via a batch processing job. And that close integration was really nice and useful for us to adopt. We also really liked a lot of the default solid settings that Databricks has for our clusters. So I remember using Spark in the past where you had to really fine-tune different jobs and different clusters to fit your job specifically. But Databricks has some default settings that out of the box are tuned to the AWS workers, so you don't have to mess as much with the Spark settings directly. And then finally, we have, some of the ML tools on Databricks are really great. Being able to build models, store your models in Databricks, track lineage on your models, and serve your models has been really great with Databricks. So talking about the kind of outcomes of our adoption first, we did a sentiment survey at our company after about 1 year of adopting Databricks to see from some of our leaders and users of the platform how they felt our platform worked before, like in AWS before we moved into Databricks, and then some of the different features that we saw after we were in Databricks. And you can kind of see that pretty much everything that we surveyed, we saw a developer sentiment improvement. But specifically, some of these items had, like data lineage, which we were looking for, had some really good improvement. Just to give you a little bit of scope about IAS and what we ended up moving in 1 year, we had 3 AWS projects, kind of our dev stage prod environments, that we moved into Databricks, moved 45 Athena databases into 112 different catalogs across 32 workspaces in Databricks, moved thousands of tables into Databricks, and you can see our Airflow DAGs actually increased because we have not only new workflows that we've created in Databricks in the past year, but we've have some dynamically generated workflows that we've been able to create and manage in Databricks much easier than we were able to in Airflow. So getting into some of the architecture for our platform here, some of the key components that we were looking into as we started this project was, first of all, we wanted to build out our platform with a data mesh in mind. So if you haven't read Zamek Degani's blog about the 4 underpinning principles of a data mesh, it's a really great read and I highly recommend it. But these 4 underpinning principles are having a domain-oriented, decentralized data ownership and architecture, treating data as a product, self-serve data infrastructure as a platform, and federated computational governance. So in the diagram on the left there, you can see what we tried to follow in Databricks was we built out different domain teams, which are different teams that that build and own different data sets, and they treat their outcoming data as a product. Then we've got the platform team, which Preeti and I work on, who provide tools and help these domain teams really operate on the platform itself. And then we have a team of reps that is the federated computational governance, which help guide us through security requirements and compliance. So with that in mind, the structure that we built out in Databricks is we have different workspaces set up for different domain teams, and then they have a catalog associated with their team as well. And so by default, we could build out all these different catalogs and workspaces for different domain teams, and then we can grant read access across domain teams for when teams need cross-domain access. Another key principle that we were looking into, or that we wanted to focus on, was using infrastructure as code. So when we built out all these different workspaces, we've used Terraform to build that out. So that Terraform created the AWS accounts, created Databricks workspaces, and defined service principals, added users to workspaces. And then it was all defined in code, defined in a GitHub repo, easily reproducible if we wanted to deploy it somewhere else. Then on the Databricks API side, we built out our own tool to manage grants for cross-domain access, access to tables and schemas. We, along with other things that we deployed in Databricks directly, like from a platform perspective. So, for example, default clusters that are available for different teams so that they don't need to spin up their own clusters to get going. We defined a bunch of serverless clusters across different workspaces so that a developer could really get into the platform running. And then following up, we've got a bunch of different enablement tools that we built out, and I'm going to pass this over to Preeti here, who's going to talk about the enablement tools.
Thanks, Andy. That was an amazing overview. It's good, yeah. So thank you, Andy. That was an amazing overview on the entire reason why we chose Databricks and our architecture and layout. I'll be going over the enablement tools that we built as part of this journey. And just before I start this, I just wanted to give a huge shout out to Databricks, the product, and also the people who supported us throughout this modernization journey. So we were able to build multiple tools and operators, but the entire reason why we were able to build these was because Databricks was able to provide us those APIs and features which these tools use internally. So with that, let's get started. Yeah, so before I get to this, a quick show of hands. How many people are familiar with Airflow? Okay, I expected that. So, so one of the first challenges that we had was there's no DS or context state variable available within the Databricks. So for those familiar with Airflow, DS is a macro that represents a partition date, like it represents a context state, which typically is used for partition date as part of the processing pipeline. So our solution was a broadcast operator that calculates the context state and time in multiple time zones and makes them accessible throughout the workflow. So the underlying feature that we are using here is dbutils, which is provided by Databricks. The second challenge that we had was rerunning a workflow with original parameters can be quite tricky. So especially if you have tasks with multiple, if you have workflow with tasks and each task has multiple parameters, you'll have to do some trick to make it rerun. But then things have improved a lot, like with the recent changes to the workflow where you can do a repair run irrespective of the status, right? So there were many new features that got added, but it still gets tricky if you have workflow with multiple tasks. So our solution, broadcast operator, actually helps us with that, where it's saving all these variables to the context, and then when you just do a rerun, all you have to do is delete those parameters and do a rerun with that. So that helped us. The third challenge is there's no generic way to store any arbitrary information specific to your workflow. So this is very similar to the Airflow variable section, where you can provide any key value pair, and all those key value pairs can be used within the entire Airflow instance. But our solution broadcast operator helped us with that, where you can pass any key value pair and that gets propagated throughout the entire workflow, and we were able to use that. And one of the other reasons why we had to build this operator also was to provide a guideline or a best practice in designing workflow. We were moving to a new ecosystem, new orchestration tool, and we wanted some guideline in designing a workflow where you say that the first task is going to be a broadcast operator which broadcasts all the parameters, and that can be used throughout the workflow. So it's kind of a best practice for the engineers. And the way you configure a broadcast operator is a pretty simple deployment YAML snippet of code, where you provide the Python wheel task, package name, the entry point, and you have created a task called variables broadcast. There's no Java, Scala, or Spark code needed here. You're just putting this in your deployment YAML. And you provide certain name parameters like the job ID, run ID, and the job trigger time, which are used for calculating this context state. And you can pass any variables, and all that gets propagated in the workflow. So one thing to note here is we are actually using the dynamic variable that's provided by the workflow, which is the job trigger time, and we are using that to calculate the context state. So underlying, it's the Databricks feature that we are using. Yeah, so the second operator that we built is related to cross-job orchestration. So Databricks doesn't have any cross-job orchestration. There is, of course, the file trigger, but then that didn't serve our use cases. So we provided this standardized cross-job orchestration where it acts as a sensor to poll any upstream tables. And not just that, you can also update the status of an upstream task so that the downstream can proceed, right? So this is very similar to the Airflow sensor, if you're familiar with the Airflow. And our solution table status operator helped us with that, where you can store all this information to a delta table, and this operator acts as a sensor and poll any upstream tables as part of that workflow. And since we are storing all this information into a delta table and using that as a sensor, we were able to solve the second challenge, which is there's no job run history over 60 days. So currently with the workflow, you can only see the historical runs for the 60 days. But we have all this data stored in the Delta table, and it's up to you to have the retention set to that data that we are storing. So we were able to solve the second challenge as well. The third challenge is kind of it's an annoying as well as a common problem in the data engineering world. So let's say I have a upstream table that got reprocessed due to data quality issues, right? So how does the downstream know that the upstream has got reprocessed, right? So with the data that we are storing with the table status operator, we were able to accomplish that. In fact, in one of the recent hackathons at IAS, there was a team that built a library that automatically tries to find if the upstream has got reprocessed and then tries to process the downstream. So that turned out to be a very cool hackathon project, and that people can use throughout IAS. And it was the enablement team who collaborated with them, and that helped them. And the way you configure table sensor also is pretty much similar to a broadcast operator. You just provide the package name, the entry point, and you are also providing the table name, partition date, and partition hour for which you are polling this data for. Okay. So the other tool that we built is related to schema management. So schema management in a big data world can be done in multiple ways. So you can have your Spark code where you say that I create a data frame and then do a save as table. And that table inherits the schema from that data frame, right? But then the downside of that is how do you keep track of when the table got changed, right? When a column got added or when a column got dropped, unless you look at the repo history, which can be quite cumbersome, right? So our solution was a DDL DML migration tool where it scans the entire repo for any SQL scripts that might have got added. And when the CI/CD runs, it executes those scripts in the environments, in the right environments where we are deploying this code. So with that, we were able to solve that second challenge, which is the restricted access to production environments, because it's CI/CD that's taking care of propagating all these changes to the higher environments, and CI/CD runs as a service principal, which has domain admin privileges. So we were able to consistently move all these changes to the higher environments and keep all the environments consistent. And here we are using the Databricks feature, which is the notebooks along with the jobs API to achieve this. Okay, so this is the other operator that we built is related to regression testing. So regression testing was a challenge for us, in this large scale modernization effort. And we had lots of tables that we needed to migrate, and if the tables has multiple columns, then that gets even more challenging. So we built this data compare operator that leverages data compy. It's an open source by Capital One to easily compare multiple tables. And you can also choose to configure the columns that you want to compare. If not, it just does a table-to-table comparison. And one of the production cutover checklists as we were going through this process was having a clear and concise format for the regression testing results, where it can show a very clear formatted output for any row-wise or column-wise comparison. And data compare operator was able to provide us just that, what we wanted. And we can also store this data to a Delta table. The regression testing results can be stored there, and so that if you want to come back and take a look at that later on, they are available for you. Yeah, and the way you configure a data compare operator also is pretty simple. You just provide the base table name, the compare table name, and the output location where you want to store this information. And the join columns is that unique identifier between the base and the compare table that you are comparing. Yeah, and this gets stored to the Delta table in the output catalog schema in the table. Yeah, so this is another one that we built, which is a template repo. So starting a project from scratch can be quite intimidating, especially if you're using a new tech stack, right? So we built this template repo for the teams who are not familiar with, most of the teams were not familiar with Databricks when we started this. So we wanted to make things easier for them. So this template repo has got certain preset configurations. We have this template repo in Java, Scala, and Python. So in your favorite language, you can just create a repo out of this template repo and then start building your workflow. And there are certain built-in Jenkins deployment settings, so you don't have to do anything special to have this CI/CD support. And we also have examples about the usage of DBFS and S3. So we typically use DBFS for all our local dev testing, but then we use S3 for all the staging and the production level environment workflows. We also have integrated this with Linter, which is a code styling tool. So you can catch all the inconsistent code styling well before things move to production. So you can also run this command locally and find out any inconsistent code styling issues with the Python, and you can fix those. And finally, the documentation. So documentation is the last thing that comes to any engineer's mind. So we wanted to make things simpler. So we built this, this has got integrated with the tech docs, and all these tech docs gets published to Backstage. Backstage is yet another open source tool that IAS uses for any infrastructure tooling or any documentation. And once this CI/CD runs, all these documentations will be available on the Backstage, and any internal IAS user can take a look at that. Yeah, so I'll be going over the demo for the template repo very quickly. I hope it works here.
Just hit the button again, I think.
Yeah, okay, fine. So this is the template repo, and the file that you're seeing here is the one that's used for your local deployment. So you see that I'm configuring certain parameters, like the Databricks domain name, the Jira project, and certain other things, which are basically used for your compute custom tags, so that you can attribute to the cost for the compute. And you also have this Databricks host and token, which is used for your local deployment. And you'll see that there are multiple config YAMLs for each environment, and this is where you have your variables for your workflow. You can have the cluster configuration or any workflow specific parameters that you might want to configure. And this is a very basic deployment YAML where you have examples for S3 usage, for the libraries volumes, and for Fuse. So we use S3 for the cluster logs and volumes for the libraries, and Fuse or DBFS is used for your local deployments. And this is where you write your documentation, and once the CI/CD runs, it just gets published to the Backstage. And this is the common.py, which is a base class for any task that you might want to create. So any task extends this task class. And if you see, there are certain instances that we are creating here, which is the Spark session, the logger, and the DB utils. And there are certain static methods also. So if you just create a subclass out of this task class, you'll have all these available, and it will be easy for development. And this is an example of a class that extends task. And you have folders for your integration and unit testing, and you can write your tests there. And this is that make file, which makes things much simpler for your development. So you have this command for lint and lint fix, where you can fix your code styling issues. And we also have a wrapper for dbx deploy, which takes a Jinja variables file. In this case, it's going to be the dev config YAML. So with just one command, you can deploy all the workflows. And this is a cool tool where you can create a repo from this template repo. This again was built as part of a hackathon event by our developer experience team along with the enablement team. A huge shout out to them once again. So if you see, we are trying to give the GitHub repo name and the repository description and certain other things like the Jira or the compliance email or the domain who is creating this repo. And these are actually used for your custom tags also. And you click on next and click on create. There are certain things that happen behind the scenes. Firstly, your repo is getting created, your CI/CD pipeline is being set up, and there are certain string manipulations that are happening which captures the information that has been given in this UI to the new repo that's going to get created. And and you'll see that the repo is ready here. And this is a basic local env where you make certain adjustments to your parameters, and then the dev config YAML, and that's where you give your cluster configuration or your workflow specific configuration. And this is that deployment YAML. So I just created a workflow with 3 tasks: the variables broadcast, the event sensor, and the event processing. Yeah, so basically I'm using all the reusable operators that I have demoed earlier, and the pipeline logic will go here. You can write your pipeline here, and yeah, and with just one command, which is make deploy, all the workflows that are in this repo gets deployed. So you'll see that the workflow that got deployed is highlighted there. I hope you can see that. And the command that gets used is the dbx deploy with the Jinja variables for your dev config YAML. And you'll see that the workflow has got deployed in our dev environment with the 3 tasks. Yeah, so it's that easy to create a workflow and start building your workflow. And probably this could relate to what Andy was mentioning about how many workflows we created in the last 1 year, which is around 1,300. So it's these tools that helped us, adopt this platform much quickly. I think that's all I had. Any questions?
Yeah, we also had a lot of extra workflows created because developers could deploy their job from local, and we prefixed, the developer's name or username with the workflow name. So we had a lot of extra dev workflows that deployed to our dev environment that added to our total